Hi everyone, I'm Shalwa Amira with student ID number 421233010X6 from Mechatronics regular class C. In this video, I will explain my program for classifying handwritten letter from the EMNIST Letters dataset using HOG feature and SVM. First, the program loads the EMNIST Letters dataset. It has handwritten letters A to Z, in 28 by 28 pixel image. The data is in CSV format. I read it with pandas and split the label's pixel value. Then I normalize the pixel by dividing by 255, so all values are between 0 and 1. This makes training more stable and avoid bias from brighter pixel. And next, I use sample 13,000 data point, 500 sample per letter. The goal is to keep all the classes balanced so the model trains properly. And after loading, each image goes through HOG feature extraction. HOG capture edge and shape by looking at gradient direction in small region. In here, parameter I use is orientation is 9. It means number of gradient direction bins, pixel per cell 8 by 8. It means its cell is 8 pixel wide by 8 pixel tall. Cell per block 2 by 2 is mean normalization across neighboring cell. Each image end up with 144 feature, which numerical represent the letter shape. I use this parameter because my computer is not very strong. They are light enough to run fast but still give useful information. If I had a stronger device, I could use smaller cell and more orientation for richer feature. And next, the feature go into support vector machine SVM with a linear kernel and C equal 1. And why linear SVM? Because it's very simple and fast to train. And second, works well with high-dimensional data like HOG. Third, much lighter than RBF and polynomial kernel. And as you know guys, since my laptop has no GPU and limited RAM, this setup makes LOOCV finish without freezing. Even with simple parameter, the results are still good. Okay, to check the model, I use LOOCV or leave one out cross validation. This means our value single sample is tested once while the rest are used for training. Here, the 13,000 times LOOCV is great because it tests the model on all data, giving a reliable accuracy. The downside is it takes a long time. In the logs, you can see guys, it took about 2.18 hours. It's not bad considering all the sample. And as you can see, here are the results. I get accuracy 82.06%, precision is 82.25%, F1 score 82.10%. The numbers show the model is quite consistent. In the confusion matrix, vertical axis it means true labels, horizontal axis it means predicted labels, dark blue diagonal it means correct predictions. More letters like K, O, X, Y, Z are recognized very well. And you can see guys, more than 440 correct out of 500. Some letters like IGR get confused a bit because they look similar. In the bottom right corner, Z has 455, meaning 465 out of 500 letters were correctly predicted. This shown the model handles distinct letters very well. So, using HOG and linear SVM, we got 82.06% accuracy on handwriting letter. Even with simple parameter due to hardware limits, classical method like this still works really well. Okay, that's it. Thanks for watching guys.